Now we're being asked to actually find the zeros of a polynomial function. That will involve using the rational zero theorem, which will involve finding the factors of 2 and 4. Remember, it's the factors of the constant term, so it's a little backwards. The last term is p, the factors are p. The leading coefficient, that would be q. So let's look at what are our possibilities for p. So we want the factors of 4. So p possibilities are plus or minus 1, 2, and 4. And the possibilities for q are plus or minus 1 and 2. So now we look at what are our possibilities for p over q. So our possibilities for p over q, which are possibilities for rational zeros, are, we'll start with the negative first. So negative 1 over 1, negative 1 over 2, negative 2 over 1, negative 2 over 2, negative 4 over 1, and negative 4 over 2, and then also the positive possibilities, which would be just the positives of these. So 1 over 1, 1 over 2, 2 over 1, 2 over 2, 4 over 1, and 4 over 2. So then we'll write those possibilities out as simplified. So this equals negative 1, negative 1/2, negative 2. We have negative 1 again, so I'll just cross that one out since we already have it. Negative 4. We have negative 2 again, so I'll cross that one out. And then repeat the process with the positives. 1, 1/2, 2. We have another 1, so I'll cross that out. 4, and then we have another 2, so I'll cross that one out. And then if we write that out in order, we could go from, negative 4, but I'll just write it out as plus or minus. So we have plus or minus 1/2, 1, 2, or 4. And we could have just done the plus or minus up here. I was just writing them all out so you could see where the actual terms were coming from, where the actual possible rational zeros were coming from. Now we use synthetic division to evaluate each possibility. So I'll start off with 1/2. I always do the positives first just because they're simpler to deal with than negatives, and we have to test all possibilities until we find what we're looking for. So I'm going to put 1/2 over here, and then we're looking at, from our polynomial, 2, 5, negative 11, and 4. 2, 5, negative 11, and 4. And bring down our 2. 1/2 times 2 is 1. And then 5 plus 1 is 6. 1/2 times 6 is 3. Negative 11 plus 3 is negative 8. 1/2 times negative 8 is negative 4. And then 4 plus negative 4 is 0. So it does go in. 1/2 goes in to our polynomial, which means that x minus 1/2 is a factor. So if we rewrite this as what we have now, it would be x minus 1/2 times, and we just go down one exponent. We're going from a cubic to a quadratic. So 2x squared plus 6x minus 8. So now we can use the rational zero theorem. Or, excuse me, now we can use the zero product property. Apologize for saying that incorrectly. So we set this equal to 0, and then we'll factor this quadratic. So we should recognize that we can factor out a 2 right off the bat. So let's just put that 2 out front. So 2 times x minus 1/2 times x squared plus 3x minus 4. Now you could go ahead and you could use the rational zero theorem repeatedly. We found one, and we have a quadratic left. You could then take what's left, x squared plus 3x minus 4, use the rational zero theorem to test the other possible rational zeros. But when we have a quadratic, it's usually easier to go ahead and just factor it, and then we can use the zero product property. So 2 times x minus 1/2 times, we know the leading term in each binomial is going to be x, and then we know it's going to be 1 minus and 1 plus because we have a negative constant and we're adding the x term in the middle. So what two values multiply to -4 and add to +3? Well, that means we're going to have 4 as our positive and 1 as our negative, because then we end up with 4x minus x, which is 3x. So this means that our rational zeros, in this case, they're all rational zeros. We end up with x equals 1/2, x equals 1. We know 2 does not equal 0, so I'm not even writing that out to the side. And then x equals -4. So the three zeros for our polynomial function, our cubic function that we were given, are 1/2, 1, and -4. Now you might end up with imaginary numbers. That's the example that you saw prior to this in the actual lesson. To check it, you can graph it, or what I'm going to do is plug the values into our original function, the original form of our function, and verify that we end up with the correct value, which would be 0. So we have x equals 1/2. We'll test that one first. So x equals 1/2. This is our check. With x equals 1/2, we have f of 1/2 equals 2 times 1/2 cubed plus 5. I said 1/2 and wrote down 1/3. So 5 times 1/2 squared minus 11 times 1/2 plus 4. I'm just going to keep on writing this off to the right. We'll do each one of them in a separate row. So that's 2 times 1/2 cubed is 1/8 plus 1/2 squared is going to be 1/4 times 5 is going to be 5/4. And while we're at it, let's just go ahead and write this one as 2 times 1/8. That's 2/8, which is 1/4. Minus 11 halves plus 4. So that ends up being 1/4 plus 5/4 is 6/4, which is 3 halves. Minus 11 halves is -8 halves. Plus 4, well, -8 halves is -4, plus 4 equals 0. So that solution checks. Now we'll look at x equals 1. So f of 1 equals 2 times 1 cubed plus 5 times 1 squared minus 11 times 1 plus 4. That ends up being 1 cubed is 1 times 2 is 2. 1 squared is 1 times 5 is 5. Minus 11 times 1 is 11 plus 4. So we have 2 plus 5 is 7. Minus 11 is negative 4 plus 4 equals 0. So both our first two solutions check. And then last but not least, we'll look at x equals negative 4. So f of negative 4 equals 2 times negative 4 cubed plus 5 times negative 4 squared minus 11 times negative 4 plus 4, which equals negative 4 cubed. That's 4 times 4 is 16 times 4 is 64. So this is negative 64 times 2. So that's going to be negative 128. Negative 4 squared is 16. 16 times 5 is 80. So plus 80. Negative 11 times negative 4 is positive 44 plus 4. Now normally we just go from left to right, but since we have a negative, I'm just going to look at what's 80 plus 44. That's 124. Plus 4 is 128. And then negative 128 plus 128 is 0. So all three of our solutions check. And that verifies that the zeros of f of x equals 2x cubed plus 5x squared minus 11x plus 4 are x equals 1/2, x equals 1, and x equals negative 4. If you graph the function, you should see that it crosses the x-axis at these x values.